Right, this is the 2015 AP Physics 1 FRQ number 5. So this is a string problem. We have our oscillator here. It's going to oscillate at the fundamental frequency. We have our mass here pulling down. That's going to provide our tension in the string. So the first question says, what is different about the 4 strings? So each of these strings have a different fundamental frequency. They have the same lengths, they have the same mass, and therefore the same tension. So therefore, taking a look at our equation, the mass density, linear mass density, must be different for each of these, right? So how are we going to say this? Well, let's just state it first. The linear mass density is different for each string. Each string, right? Because, well, since V is proportional to frequency, right, because, well, V equals F lambda, we'll just write that V equals F lambda, so V is proportional to frequency, so the velocity is decreasing as the frequency is decreasing. Okay, since the tension is equal in all strings, then V is proportional to 1 over the square root of m over L, which is the mass density, right? Okay, so anyway, it's same in all strings, so it's proportional to mass over m. Okay, therefore m over L is increasing to decrease velocity. Okay, all right, letter B. Student's going to graph frequency versus 1 over the linear mass density, the inverse. Will that graph be linear? So we kind of already derived that here earlier, so somewhat. So we know V is proportional to F, right? We know V is also proportional to 1 over square root of m over L. Therefore, probably should be writing this in sentence form, but anyway, therefore F is proportional to 1 over the square root of m over L. Okay, so in other words, the answer to the question is no, it will not be linear. Probably I should have said this first. Because F is proportional to 1 over the square root of m over L, not 1 over m over L. Okay, in order for it to be linear, and I know they're not asking this, but let's just answer it anyway. In order for it to be linear, the student must graph frequency versus 1 over the square root m over L, or yeah, square root. Okay, something like this. F1 over square root m over L. That's going to create a linear graph. All right, last question, letter C. Okay, we have the frequency of our oscillator. is changed, so it said its second harmonic, mark the points that have the greatest average vertical speed. So the second harmonic is going to look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our node's going to be in the middle. The second harmonic will look like this, right? Okay, so they're asking about the greatest vertical speed. So some points on the string will have the greatest vertical speed. So clearly the ones that have to go the greatest distance, that would be right here and right here. Let's just label this A and A. So these would be the antinodes. Have the greatest speed. They're not asking you for the reason, but hopefully you can see this is where they go the maximum distance here, right? So this would go the full amplitude, or I guess 4 times the amplitude in one period, each of those. I'll just write the reason. Probably shouldn't, but they travel the greatest distance. I guess that's redundant. Okay, they travel 4 times the amplitude. All right, sounds good.